Hello, welcome to Math Smart. In today's lesson, I'm trying to help students who face difficulties and challenges in problems dealing with algebraic expressions. I'm trying to explain the concept of algebraic expressions using simple explanations and simple examples. So let me begin with my explanations and let me show you the way I can explain the concept. So we will be learning about expressions in the lesson for today, and we will be covering what and how about algebraic expressions. You will see in the coming slides that the expressions include numbers and alphabets. Numbers as we hear, as we use them uncountable times during our lifetime. And alphabets, we have normally used alphabets in languages, in spoken words, but how can we use alphabets in expressions through math? Here is an example. The numbers, we know they include mixed values. They express mixed values, fixed values. That means the numbers are 10, 14, 200, -17, -250. So if you see all through these examples, the numbers are having all the values that we have learned so far, be it positive numbers or negatives. So this includes integers as well. Whereas alphabets are representing certain values in our expressions and mathematical statements, which are unknown, which we are still to find out. So we call them alphabets or variables, and they can be any variable. For example, I have chosen M or Y or P or K, or the most common one, X. So you will see how we will be using a combination of numbers and alphabets to solve certain problems. But let's understand how we include these alphabets in our numbers. So to understand, to start with, if I say I am adding 1, then another 1, and then one more 1, what's the answer? The answer is a simple 3. But if I say you have to buy something whose price is P, you buy one more item with the same price, that's P again, and you buy a third item with the P. How much price would you be paying? You will be paying 3 times the price you were paying for one of the items. That means the variable here is the price. The variable is how much price you were paying in the beginning. You don't know how much price you were paying in the beginning. So if you were paying a $10 before, you will be paying 3 times the price now. That's $30. If you were paying a $5 before and you're buying 3 such items having the same price, you will be paying 3 times $5. That's $15. There's another example. Here I have changed the number. If you notice, the number in the red here has changed. So if I was buying something, or I was running, let's say I was walking for 1 meter distance before, then I walked for 1 meter more, and then I walked for 2 meters, my distance traveled would be 4 meters. That's simple to say. But if I say I got something, let's say M represents the minutes. Okay, so you read your book for some minutes on the first day, you read the book the other day for the same time, that's the same number of minutes. And the third day when you read, you spent double the time reading the same book. So here if you see, I have added the same time on the first and the second day, but I doubled the time that you spent on reading the third day. So how much was the total time spent on reading? It was 4 times of whatever you spent on reading on the first day. So if I say that you spent 10 minutes on first day, you spent 10 minutes on the second day, the third day you spent 2 times 10 minutes, that's 20 minutes. So these are just simplest examples to explain how we will be using numbers and alphabets together to make sentences. Here, if we try to add some expressions, let's see. When we are adding numbers, that's pretty simple. If we are adding numbers, it's easy. I'm adding a 2, I'm adding another 2, and then I add a 5. That makes simple 9. But over here, I'm adding alphabets. So the alphabets are the variables. I have 2 times y, I add another y, and I add 5 y's more. So how many y's do I have together? I have 9 y's together. In another example, I have changed the variable, that's x. So if I add 10x before, and then I have few more x's to be followed, how many x's do I have together? So the thing here to notice is that when I'm adding the alphabets, I'm just adding the numbers before the alphabets. And what is this called? The number before the alphabet is called coefficient. So this is what it is called, coefficients. So these are the coefficients that we are adding to just find out how many of such variables we have together. One interesting example here again. So if you see, I have, I think, yeah, this is what I can pick. So if I have some variables that I'm adding, but in the same expression, I have a different variable to be added, I will not just go about adding everything together. Instead, I will be picking the alphabets that have the same appearance, what we call them. So to make it simple, we call these terms like terms. So we always add the like terms together. So we would be making groups. So I would make groups of some numbers. Let's say the first 2, since you can notice that they have the same alphabet. So they are like terms. The other group, which is having the same alphabet, M, that's another group of like terms. So I would be adding P's and M's separately. It's like adding the apples and the pears separately. I cannot mix the apples with the pears. Yes, I know they all represent the fruits. Same way, all these numbers in the expression represent algebraic expression and they are part of it. But I cannot add them all in the same way. I have to make groups. So let's say the P represents the pears and M represents the mangoes. So I have 22P and I have 9M. I hope this makes the concept of adding the algebraic terms clear. Now let's see what's next. Here we have the next slide. One moment. So here we go and share the next slide with you. This one. So let's see. If you have to check your understanding of what you have learned in the previous slides, how the terms of expressions are being added, how you would do it. So in the first case, you're having 1, 2, 3, 4, 5 terms. So how would you be using these 5 terms to add? So I will be saying that I would first pick the terms having the same variable. And if you notice, interestingly, the signs have also changed. So the 3 terms that contain a P, some of the terms are positive, but the third term is a negative. So here comes the role of integers. So if I start by solving the P's first, I have 6P and I have 3 more P. So I have together 9P. And then I subtract a 4 from there. I make 5P. That's here. Now, I move towards my other variable, that's the X. So I notice both the terms are positive since there's a plus sign here and there's a plus sign here as well. So I go and add the coefficients with the X directly without any breaks, without any interruptions, because there is nothing else I have to consider. So I have 2 and 5, that makes a 7. So that's the answer for my first expression. Now let's see if I have to add the next expression in this next step. I have the variables y and y, and then I have the m's together in the other group. So if you have seen, I have a positive 10 and a negative 4. So I have 6y. On the other side, I have 8 and 6. That's positive. So when I add 8 and 6 and subtract 3 from it, I make 11. So I've got my answer, 6 times y minus 11 of m. One more time, let's review. So if we have the 3 terms like this, I hope you are guessing the answers well. And yes, it's not about guessing, it's about understanding more. Yes. So we have 25, negative 13, and positive 2. So when you have 25 and 2 positive, and you subtract a 13 from there, you make 14. So we have the variable accompanied, that's coefficient 14 with the variable x. And then we have the other pair of like terms, that's y's. So how many y's together we have? We have 12 y's. So here we have the explanation and a review again for the algebraic expressions. I hope my previous slides and these examples have helped you well to understand the concept. I will be coming up with my next videos soon to help you for subtracting, adding, multiplying, and dividing algebraic expressions. But until then, keep checking for more videos and do like Math Smart. Bye-bye. Thank you.